Hello guys, in this video I am going to explain the solution of this question number 1 from chapter 9 of the book Engineering Circuit Analysis by Hayt, Kemmerly and Durmi. So the question says that for a certain source free RLC circuit, we know that the RLC circuit, it is just a parallel combination of resistor, inductor and the capacitor. Resistor, inductor and capacitor. And over here we assume that this node voltage is V, and once we assume that this node voltage is V, it means that the voltage across the three elements, resistor, inductor and the capacitor, it is also V, because as per the parallel combination, the voltage remains same in all the parallel branches. Now coming back to the question says that for the source free RLC circuit, R and C is given, and we need to determine the L such that the circuit response is overdamped. So we need to determine the value of L such that the circuit response is overdamped. Now overdamped, what is overdamped? The condition of overdamped is that alpha should be greater than omega naught. Now alpha, we know that alpha it is given as 1 upon 2 RC, whereas omega naught it is expressed as 1 upon 1 upon root LC. Now substituting the value of R and C in the alpha, we will get R is 1 upon 1K, so it will be 10 power 3. C is 3 microfarad, so it will be 10 power minus 6, right? So this can be written as 10 power 6. This can be taken at the numerator, and then 6 into 10 power 3. This and this will cancel out, so we get 1000 upon 6, so it is 500 by 3 radian per second, right? Now omega naught 1 upon root LC. So L we do not know, and C it is 3 into 10 power minus 6. Now taking this condition of overdamping, alpha is greater than omega naught, or we can say alpha square is greater than omega naught square, right? So alpha square, alpha is this is our alpha. So alpha is 500 by 3 square greater than omega naught is this. So we can write it as 1 upon root L into 3 into 10 power minus 6 whole square. So solving this, we get greater than 1 upon L into 3 into 10 power minus 6. So rearranging all this, so L can be taken over here on the left hand side. So L is greater than 3 upon into this 10 power minus 6 can be taken in the numerator upon 3, right? Sorry, it is over here, since it is 3 square, so this will become 3 square, so it will be 9, and this will over here also it will be 9, right? So now solving this and this will cancel out, right? And this 4 zeros will be cancelled out, it will become 100, and this 25 and 4. So it means L is greater than 12. This is the condition to make the response overdamped. The L should be greater than 12. So we can select, since in the question it is given that we need to determine the value of L, so the range is L should be greater than 12, and we can take any value of L that is greater than 12. So let us take the value of L as 16. The reason I selected L as 16 is to just get my calculation simple, calculation that I need to do for the second part. And the second part says that we need to write the equation for the voltage across the resistor if it is known that voltage at 0 minus is this 9 volt and the voltage differentiation of the voltage at t equals to 0 plus, it is 2 volts per second. Now from this initial conditions, now means two initial condition is given. One is this. Now we know that if the voltage at 0 minus is 9 volt, now the same voltage will be there at 0 plus also, right? So this is the first condition, and the second condition given is dv by dt. This is the second condition, so it is dv by dt at t equals to 0 plus, so it is equals to 2 volts per second, right? So now we know that for the parallel RLC circuit, the voltage, it is given as, it is expressed as a1 e power s1t plus a2 e power s2t, right? So over here, first of all we need to determine the s1 and s2, and then we will need to determine the a1 and a2, which are the constants. So to determine the s1 and s2, simply we know that s1 and s2, s1 and s2 can be determined using the equation minus alpha plus minus alpha square minus omega naught square, right? So this s1 and s2, we will substitute the value of alpha. What is alpha? Alpha is this that we have determined. So this is alpha, right? This is alpha that we have determined. It is 5 minus 500 by 3 plus minus 500 by 3 square minus omega naught. What is omega naught? Now omega naught we need to determine, because we have determined, we have selected L as 16. So with this value of 16, we need to determine the omega by substituting the value over here. So substituting the value over here, 1 upon omega naught. Omega naught is equals to 1 upon L into 3 into 10 power minus 6. So, and the L we have selected is 16. So it is 1 upon 16 into 3 into 10 power minus 6, right? So this we can write it as 10 power minus 6. It can be taken into in the numerator. It can be taken in the numerator. So okay, so 10 power 6 upon 16 into 3, and this, let me, this can be written as, since it is under root, so 10 power 3 for root 3, right? And this upon 4 root 3, and this, or hence omega naught is equals to, this can be cancelled, like let me take it as 500 and this as 2. So this is radian. So this is our omega naught. Over here, note that I can cancel this 2 also, but I have not done it, just because like in the upcoming calculation, if I keep, for the upcoming calculations, if I keep the value of omega naught as this, then it will become simple. So it is the reason I keep omega naught as this. So now substituting this omega naught in this to calculate the S1 and S2. So substituting the value of omega naught, you can see that alpha is 500 by 3. So it is the reason that I for the omega naught also I kept the value as 500 in the numerator. So omega is 500 upon 2 root 3 square, right? So it is minus 500 by 3 plus minus, taking this 500 by 3, or we can, this omega naught can also be written as 500 root 3 upon 2 into 3, right? So just I multiply and divide this by root 3. So this I will get as 500 root 3 upon 6 upon 6. So just a minute, let me do, yes, upon 6, yes. So instead of this I will take this root 3 upon 6. So now if I take this 500 by 3 as common, so I will get 1. For this it will be 1, and for this it will be root 3 upon 2 square. So over here minus 500 by 3 plus minus 500 by 3 square, and this is 1 minus 3 upon 4. So it is minus this is, remember, this is S1 S2. So S1 S2 is equals to, and then this under root can be removed, 2, we will get this, right? So it is minus 500 by 3 plus minus 500 by 6. So minus 500 by 3, 1 minus 1 by 2, right? So S1 S2. So we get the two values as 1. So it is plus minus. Over here it is minus plus. We can write it as minus plus. So the first value, if we take minus, then we get minus 500 by 3, 1 minus 1 by 2. Second value, 1 plus 1 by 2. So it is minus 250. This term it will become half, so that half will be cancelled, or let me put it complete. So these are the value of S1 and S2. Now substituting this value in this equation, we will get Vt is equals to A1 e power, first value is this minus 250 upon 3, and then 250 minus 250 by 3 t plus A2 e power 250 minus 250 t, right? So this is our equation. But now over here we need to determine the A1 and A2, and A1 and A2 can be determined using the initial conditions, these conditions. Now over here it is given that the value of v0 plus it is 9. So substituting this value we will get, it means that 0 is equals to, at t equals to 0, it is a1 e power minus 250 into 0 plus a2 e power minus 250 into 0. So it will be 0 is equals to a1, this term will become 1, right? So a1 plus a2, sorry, not 0, it is 9, it is 9. So this is our first equation. Now to determine the second equation, what we need to do, we need to differentiate this. So if I differentiate this, I will get dvt by dt, and the differentiation will be minus 250 by 3 a1 e power minus 250 t by 3 plus or minus 250, I differentiate this term, so 250 a2 e power minus 250 t, right? Now substituting the value of dv by dt at t equals to 0 plus, it is 2 volt per second, right? So it means 2 is equals to minus 250 by 3 a1, and this term after substituting t equals to 0, this will become 1, right? So minus 250 a2, and then again this term will become 1. So this rearranging these equations, we get 6 is equals to minus 250 minus 750 a2 or a1, or minus 6 is equals to 250 a1 plus 750 a2. So this is our second equation. So now we have these two equations. First equation is this, second equation is this. Now if we solve these two equations simultaneously, then we will get the value of a1 and a2 as, just a minute, yes, so a1 is 13.512 and a2 you will get it as minus 4.512, right? So once we get a1 and a2, now we can substitute this value of a1 and a2 in this equation. So our vt it is equals to a1, so it is 13.512 e power minus 250, then minus 4.512 e power minus 252. So this is the voltage, right? Voltage means which voltage? It is this node voltage, and as I already told in the starting that this voltage will be the voltage across R, this voltage will be the voltage drop across L and across C. So all the three voltages are equal. So the question, as the question is asking that we need to determine the equation for the voltage across the resistor, so this V that we have determined, it is also the voltage across the resistor, right? So this is the solution to this question number 1 of this chapter 9. So if you have any doubt, you can put it in the comment box. Do subscribe my channel and share this video with your friends and colleagues.